Okay, I mentioned that we'd look at current a little bit. So what if I have an issue here where I can't see current flowing? Okay, I may have to actually measure the current to make sure there is current flowing. If there is current flowing, then that's great. I can do a voltage drop test. So let's take a look at the meter again. To measure current with my meter, I'm going to have to change the position of not only the selector, but I'm going to also have to change the position of the leads. Okay, now again, I need to measure direct current amperage, so I'm going to go to the big A here. Okay, now the big A with this particular meter is able to measure 10 amps. Okay, that's maximum before it'll blow an internal fuse. So I'm going to set this over to the big A. Let's take a look at that display. Now, as I mentioned, with this particular meter, it defaults to AC when I go to current. Okay, so what I'm going to need to do, as I mentioned earlier, with this particular meter, I push the yellow, and now I'm measuring DC current. That's what I need to be. This is a DC power supply. Okay, let me zoom out a little bit here. Okay. I mentioned that I also have to change the leads. Okay, my red lead is going to have to come out from the volt, the ohm, the temperature, and it's going to go to the big A. Now, I always want to start out at the big A. I want to start my meter with the largest range that it's capable of measuring. Reason being is I'm not exactly sure whether the amperage I'm going to measure is less than the smaller amperage scale. If I look at the smaller amperage scale here, this meter will blow its fuse at about 400 milliamps. So that's 0.4 amps, so less than an amp, or half an amp, will blow that fuse. So unless I'm absolutely certain that the amperage in the circuit is going to be 400 milliamps or less, I am going to begin my measurement with the meter in its largest scale. And for this meter, 10 amps is the largest scale. Now, when I'm measuring the current with an ammeter such as this, I need to place this meter in series. It's kind of like measuring the water flow or the fuel flow. This little device has to be in the series. It has to be in the pipe where the fuel or the water is flowing so it can measure it directly. So that's what I have to do with this meter. Now, one thing to be very careful of with a meter set to measure amps, the lead's in the right place, the selector in the amps, you can do some damage to your meter or to a circuit. So think of this as nothing more than a straight piece of wire. Now, you don't want to put a straight piece of wire directly on the battery voltage and directly on battery negative, because you're going to cause a very high amperage flow and you're going to melt the wire, possibly damage the battery. So think about where you're placing your leads here. We need to make sure that it's in series with a load. Okay. All right, now, in order to place it in series, I have to open the circuit somehow. So with this particular circuit, it's pretty simple just to open it right here at the ground, or I can open it right here where the ground wire comes into the bulb. All right, now notice the bulb has gone out because I've opened the circuit. Okay, I'm going to put it back in. There we go. The bulb's back on, dimly as it is, but it is on. I have current flowing. No current flowing. So when I place my meter in series, that light bulb should come back on. And there it is. Now we can see that I am pulling right at 1/3 of an amp. Now, I know this light bulb pulls much more than 1/3 of an amp, but we can talk about that a little later. What this tells me is there is amperage flowing through the circuit. I do not have an open circuit. Because I have amperage flowing through this circuit, I can now do a voltage drop, being completely confident that the readings will be true. Okay, let me remove this and put this back in. Okay, so amperage. If I know what the circuit is supposed to be and I measure the amperage and it is substantially less then I know I've probably got some unwanted resistance somewhere in the circuit. If the amperage happens to be more, it's a possibility that something has been spliced in parallel with the circuit, or perhaps I have a short to another circuit somewhere. So, now, something very important, anytime you measure amperage with your meter, as soon as you're done with that measurement, it's a very good practice to set it back up to measure volts or ohms, so that, again, you don't blow your meter or cause damage to the circuit.